Hello, good morning, everyone. Hope everyone is doing great. So I guess I'll be getting started with a very small keynote. I'll quickly start sharing my screen. But before that, thanks everyone for joining. I can see the numbers going up and up as the time progresses. So thanks so much for joining. Hope everyone is doing safe. So today's short keynote will be a little bit about my experience going through automating different devices or different cases, maybe starting from web browsers to mobiles to different thing. Every automation or what sort of any medium of automation that you do has something in common, which is nothing but flakiness, right? So that is something that I'm going to talk about in a very short note, like around 8 to 10 minutes, I believe. Let's just quickly start sharing about that. Okay, I hope you can see my screen.
Yeah, Manoj, we can.
Okay, cool. So let's start with signs of flakiness. Who doesn't like flakiness, right? Or who doesn't like snowflakes? I mean, doesn't make really sense to talk about this in a summer, especially me coming from Chennai and many places of India are already facing the heat, and at least a few places in India are having some sort of rain downfall, which is literally good. But then snowflake is something very nice. I really love physics, and I read as and when I get time, or even watch science fiction movies and stuff like that, which becomes very interesting when you really love and understand what it takes, right? Unfortunately, I didn't love physics until I was passing out my 12th grade. I really started loving science a little later, but then realized what it takes to understand the things happening around us, right? So one of such things is snowflake. And it's very important, right? So just to give you a brief about how snowflake forms. Snowflake actually begins to form in an extremely cold weather. In an extremely cold water droplet freezes onto a pollen or a dust particle in the sky. So this creates some sort of a thing called as an ice crystal, right? So in especially in winter, the air up there can be very cold. I mean, this is applicable wherever you see snowflakes. It could be you could be in any wet region, or even in dry region. Some winters, extreme winters and cold seasons, you do feel the coldness, and some at least you'll be able to see some sort of hailstorm, or at least some sort of snowflakes coming into picture, right? So in order to have the snowflakes form, so the clouds which we see, right, so that needs to be below the freezing temperature. But also understand it shouldn't be too cold, right? So snowflakes actually form within the moisture in a cloud, right? So if the air gets too cold, a cloud won't hold enough water for anything to precipitate out. So there has to be a good balance between how snowflakes can be formed. So that's why if you really see, most of the flakes develop or just below the freezing temperature of somewhere around 0 degrees Celsius, at least around 32 to 33 degree Fahrenheit. So snow can form in a cooler environments, but the colder it gets, the less moisture will be available to make even a snowflake, right? And that's really about snowflake. And the reason why I've termed it as science of flakiness is because I want to tie or draw an understanding between how snowflake, and environmentally it's good to understand snowflakes because of the global warming that we really see, and the cloud carbon fruit and every companies are doing. I think there's a lot of companies making efforts like Google, Microsoft, and even ThoughtWorks. We developed an open source framework where we can, it's available open source in GitHub, where you can use that framework to figure out how much carbon footprint that you're utilizing, and how much you could improve as well. So every companies are moving towards that. So the awareness is neat, and one of the things that I wanted to again bring to notice here is, while we understand the global warming stuff, and how we want to embrace having the Arctics and Antarctics not to be melted down, right? We'll all be looking like the 2012 movie or the day after tomorrow movie, right? So we don't want to happen that. So snowflakes is all about different patterns, right? I'm not sure how many of you know about snowflake patterns, but like our fingerprints, no two snowflakes are exactly alike. In fact, they are so diverse, and there is even actually an international classification system of how snowflakes really work. And that can be broken down into, as far as I remember it, there are around 6 to 8 principles of how different snowflakes can be, right? And people also claim that snowflakes are symmetrical, but actually they are not perfect. And there is also saying that no two flakes are different, right? So, or why no two flakes are different? So that is a question to be asked, right? If you see the picture that I have, you can really see two different patterns within our snowflakes as well, right? So, well, that's because individual snowflakes follow a slightly different paths from the sky to ground. So it's a long story on how snowflake really forms, from the cloud until it hits the ground, and a lot of things goes between that, as I was just giving a brief about it. I'm not going to all deep in that because it's just a 10-minute talk, and moreover, this is not a physics talk. I just want you to understand how things get counted, right? um, so as I said, so individual snowflakes follow slightly different paths from the sky to the ground, and they encounter slightly different atmospheric conditions along the way. And if you really see, the key word here is slightly different atmospheric conditions. So these atmospheric conditions really make the shape of the snowflake, right? So therefore, all they tend to look resembling, but they are not exactly the same. Some may look like prisms, some may look like diamonds, and some may look like neat flower shaped snowflake. And they all form a lazy pattern, but they look similar, right? So each pattern is very different. And what are you going to do with this snowflakes? Well, it's completely up to you. Whether you could be a so-called matured person who can just wipe away a snow from your car and just walk away with your day-to-day responsibilities. And you can actually tie this with your test automation flakiness, right? So we all know that test automation is there, pretty much happens from a UI layer. I'm talking about things that you do automate in UI and in mobile layer, right? So we all know some test cases fail for no reasons, and we yet sometimes we rerun, sometimes we do many stuff, or sometimes we just patch it up so that we don't get to see them a red color light, or someone falling down on my Jenkins build or somewhere. But it's really up to you. It could be, as I said, it could be a mature adult who can use any sort of ways, like physically people in the snow region, someone ultimately they don't have any choice, other than if you're varying from different age to whether you could wipe out your snow and walk to with day-to-day reasons, or even you could be a happy kid like this where you can decide to play with it very happily, right? That's the different perspectives that I want you to bring. Like snowflakes are different, snowflakes are there for a reason, and it is a beautiful thing. And similarly, test the flakiness in test automation. Well, I wouldn't say it's a beautiful thing because I've been working late nights to fix them some of the times. But I hope each and every one of you have done at least some sort of test, and you'd have been facing the flakiness, and you'd be wondering why that happens, right? And similarly, as we figured out, the snowflakes has different patterns. There is an international classifications around it. Whether you enjoy it or whether you monotonously do the same thing, it's completely up to you. But I would rather focus you or suggest you to choose the second path, just like this happy kid, right? So just play around with and understand the patterns that the test automation flakiness brings in, right? Because it has its patterns too. Just blindly rerunning your test or fixing your test just for that build doesn't make sense at all. The pattern include many things such as synchronization, network related issues, browser device issues, locators issues, environmental issues, and many such errors, right? Like say, for example, from a synchronization perspective, it could be page load issues because we are dealing with something in the presentation layer. I hope you all remember the OSI architecture, which we all studied in our engineering, right? So the presentation layer at the very top. So imagine that we are working with or interacting with something at a presentation layer. So things tend to get flaky, and it's quite natural, just like how the snowflake happens in the planet Earth, right? So just embrace them and understand what happens behind it. And similarly, network, it could be running in an unstable network. You could be running through a VPN. It could be running through different containers for that matter. Or you could be, your test could pass in one browser and may not fail in other browsers. It could be happening in different devices, right? And it could be, we are working with web and UI, right? Or even desktop automation for that matters. It could be your locator issues as well. As I mentioned, it could be environment issue. There are many things, that constitutes to what is flakiness, right? So which is for the test automation flakiness, as we say. So I would say it is an opportunity to relook and fix them as a permanent thing, or don't patch it up, right? If you're thinking, okay, I'm running my test automation suite and I have something failing. Some intelligent test frameworks out there claim that they have self-healing test, or they even say that we have retry mechanisms, automated retry mechanisms, and stuff like that. I know a couple of you, we do that. Like, say for example, as I've seen people using a Java-based TestNG framework, having some sort of retry mechanisms, right? Say I'm running like 50 tests, and out of which 10 fails. Pick the 10 test and rerun it. Well, it's a quite natural thing to do. So that's more like a person who is wiping a snow out of the car, right? So just imagine that perspective. But unless if you want to be a kid who enjoys the snow, well, you should actually fix them by looking at deep dive. What is the pattern? So retries, reruns are not the solution to fix your test automation flakiness, but rather understand it's an opportunity to fix them permanent. It could be because of various reasons. Because when you wrote your test in your local environment, it could be different. But rather, when you run it under different systems, like different environments, it's totally different. So see this as an opportunity and relook at them. So we are evolving from a phase where we have started automating using tools like Selenium or Appium, to now we are looking at automating things like AR, VR, or even wearable technology like that. So with that, I'll take a leave here. So thank you so much for this opportunity. I hope you enjoyed a very short experience sharing, more of, I wouldn't say it's a keynote, but more of an experience sharing. So the technology is evolving, so keep pace with it. So don't keep thinking about flakiness as being a major hurdle for test automation. So just embrace it. Look forward to many such sessions and interactions with you people. With that, we have two exciting sessions, as Vignesh mentioned earlier, wearable technologies and load testing, where most of a lot of flakiness would also be encountering there. I hope both of you will touch at some point. With that, thank you for the opportunity, and over to you folks.
Thank you, Manoj. Thank you so much. That was an interesting talk. Uh, so, who doesn't know about Selenium? I guess whoever is there in the testing world, somewhere they have heard or used the Selenium. Manoj is a major contributor to the Selenium, and also he is a part of a leadership Selenium leadership committee. So that's it. It's not only Selenium. I guess he has contributed to many of the open source. Yeah,
He
that's
has a huge list, Shweta. It'll take a long time.
yes. Cool.
So thank you so much, Manoj, for joining in your busy time. And it was a very good to compare the snow and with the flakiness what we have in automation. I was just wondering why Manoj is showing something in snow. So at the end we got to understand that each patterns are so different. That was a very good analogy, Manoj. Thank you so much.
Yes. Okay. I think we are slightly delayed, but on time. We can get started with our first talk, that is related to the interoperability testing for the variables. So over to you, Bharathan.
Uh, Bharathan, you're speaking on mute, Bharathan.
Okay, thanks, Sweta. Hope my voice is audible and clear. Loud enough?
Yeah,
Yes.
Bharathan. Yeah.
Okay. And hope my screen is also visible now.
Yeah, it is visible. But I just wanted to hear from the attendees that is it visible, guys? Just put an yes if you see the screen. Yeah, Bharathan, we are getting many yes. Yeah, we can get started.
Okay. I think my topic is going to be on interoperability testing for wearables. So in this topic, we are going to look at the nuances to watch out for testing in wearables and Bluetooth communications. I think everyone would have done various different types of communication testing in terms of our day-to-day life, starting from our internal communications with one service to other service or service to the application. This is similar to that, but the only thing is that today's agenda is going to be more on the communication of how Bluetooth communicates and what are the things that we need to look out for it. Okay. So I think let me introduce myself. So I'm Bharat. I'm part of ThoughtWorks for the past 5 years or above. So I have interest in various domains like airlines, retail, insurance, and now my recent stint with ThoughtWorks gave me the opportunity to work with Bluetooth technology also. So, and that is the session is also going to cover up. Okay. So what we are going to cover up in this session is what are wearable, what is how Bluetooth talks to or communicates with other devices, and how we are going to specifically look at in terms of testing what needs to be taken care. So the wearable industry started around like after late 1995. So when they wanted to track many personal related information. So how do you define a wearable device? Any device which collects data continuously and have the capability to send data to other device can be categorized as a wearable device or widget. The most common ones that we know are smartwatches, smart glasses, but apart from that, there are many wearable devices that are there in the industry, like chest strap. This is specifically needed for persons who are having art-related ailments, and there are head bands or head helmets, which also constitutes for a construction worker what are the impacts that it is creating and collecting data over those things. So Caterpillar uses those specific wearable devices. So, but the most commonly public wearable devices are these things. And what are the different types of wearable communications that we have? The most initially part that was used was the RFID, which basically sensor receives data with basic information. Basically, a RFID will have a unique ID, and it can send the timestamp. Certain devices have a capability to send the timestamp also. So a basic example of that is a metro card that we use in metro train, or like you can consider the toll booth scanner that we have recently introduced across India. The next comes as the GPS wearable devices. This was predominantly used for people who are in the European region who are more fantasized by losing their personal pets. So they came up with something called as dog tracker, and this is now used widely in terms of courier and logistics part. GPS tracker will be part of many things, but in terms of it acting as a wearable is also there currently in the industry. And then the most widely used one when the industry started with the revolution of Bluetooth is in 1996. And then the mobile industry started using the concept of Bluetooth communications. And then it was again incorporated to the wearable industry also. And Bluetooth communications, you know, that headset and physical trackers, these use Bluetooth communications. And recently, right, it not necessarily the wearable has to talk only to Bluetooth via Bluetooth. Now you have the wearables that is almost like a mini mobile device, and they also connect directly to over the internet. So something like a Samsung Smart Gear or Apple Watch. I'll hold down now if there are any questions coming up.
Guys, put up your questions in your Q&A section. Do not put it up in the chat so that it will be easy for the speakers to pick it up and answer it down below. If you have any questions, please put it in Q&A.
Okay. Hopefully, I'm going at a normal phase. So now let's come to what is Bluetooth communications. So any communication which is a wireless communication. This was started way back in 1996 by a group of 3 companies which were like predominant at that time. Intel, Ericsson, and Nokia came together. There were different communication that was proposed as a standard to replace the wired based communications, but unanimously Bluetooth was chosen. And the interesting part of the naming of Bluetooth is it's actually a name of a Scandinavian king called Errol. His teeth become blue after he died, or uh, but the concept why they named it as Bluetooth is that king unified many different Scandinavian countries when during his rule. So that's the name of the that's how the name came as Bluetooth. And even the symbol of Bluetooth, it's a Scandinavian representation of H and B. You can see a two-headed fish-like symbol. That's how the even the icon of Bluetooth came. So Bluetooth, basically how it operates is it has a concept called master and slave. A master can send and receive data, whereas a slave can also send and receive data, but a master can communicate to multiple devices, whereas a slave can communicate to only one devices at any point of time. Okay, so in this case, let's say in the example of mobile and a smart watch or a wearable device, the smart watch is will act as a slave, and the mobile device will act as a master. This network of master and slave, whereas the mobile devices can also be connected to a headset, also be connected to any other Bluetooth devices. This entire network of Bluetooth communication, they call it as piconet. So, and once they make a peer-to-peer connection, I think I'll come to the pairing part. So this entire network is called as piconet. Okay. Now, coming to the important part, right? How does the master and slave talk to each other, and how does the master or the slave knows it for the first time? Okay, so now this comes to the part of the Bluetooth pairing. So there are different versions of Bluetooth. Now the latest version of Bluetooth is 5.2. Most mobiles started adopting this one, and Apple and Samsung were the pioneers in terms of adopting this. So the initial legacy pairing was just a peer-to-peer connection. I sent a message, the receiver will receive it. So you would have also heard about something called as, in the older days, we used to even send images and text messages via Bluetooth, and there was another way of communication called infrared. So where there is no security in terms of that, at any time I can send the same message multiple people without having some kind of validation or security thing. The receiver will not know from whom this is coming. So that is the initial legacy pairing. And then came a secure simple pairing. What does this is? Once the slave connects to the master, it will not be able to connect to any other device without disconnecting from the master again, or we have to reset the entire device. So this was simple secure pairing that was there initially. Then we have the numeric comparison. If you can recall, if anyone have used a Chromecast device pairing, right? The Chromecast displays the videos via the internet, basically Wi-Fi, but the initial pairing needs Bluetooth enablement. And if you are observed, right, there will be a number displayed on the mobile device which you are trying to connect, and the television which you are trying to connect. A similar string will be displayed on both the devices. This is called numeric comparison, but Google uses it as alphanumeric. Basically, it's a string comparison. This is to ensure that you are connecting to the right device, so that none of the, because we can have Chromecast in multiple neighborhoods, so that we don't connect to other devices and nobody connects to our networks. And the other secured way of doing is a passkey entry, where the slave device will, I can show you that the slave device will give a numeric entry. It may be a 4-digit to a 6-digit entry code. Sometimes it's a unique entry code, or sometimes it can be, they also provide the option of TOTP, similar to a Google Authenticator. It is a authentication key generated at different TOTP. Okay. And the latest one is like out of band Bluetooth pairing. If you look at the latest Apple 3 watch, they will not give any numeric code or passkey entry. It will be displaying a unique image of a cloud cluster, and you have to turn on your Apple camera in the mobile device. It will understand the unique cluster that has been sent by the Apple Watch. And similarly, Samsung has their own way of doing it. Okay, maybe I can show how the passkey entry is there in a bit, while I'm showing the actual the physical device that I'm going to connect. Okay, I'm going to the next one. So maybe I can give my high-level application context. So basically, I was working for a health and fitness tracking mobile app. It is similar to a cult app in India, like how cult app makes the end users to join multiple sessions like yoga, workout, or cookery or karate classes. Similarly, we can. This is an app based out of Europe. What it does is the project, the mobile project add a customized fitness device. Why customized devices? They want a specific set of devices in their own format of data. So they didn't go for any publicly available devices like Fitbit, Garmin, Polar, or those kind of things. So they went for a customized. There are multiple in cloud in public, right? There are multiple companies who provide customized device manufacturing and then customized to the requirement. So the ideology is get data, make the user to buy these customized fitness device, and get data from these device to the mobile app, and then do some normalization or extraction and send this data to the health platform. And this health platform is not only for this specific mobile app or the company. This is used across various industries, so that this can also be sent as a data when you are visiting to your doctor. So it was like that kind of integration that the application was trying to do. Okay, since due to security concerns, we'll be not able to show the actual app or the actual end-to-end working of the web. But what I'm going to do is I'm going to show you a similar behavior which is already there. So I'm going to use a Garmin fitness device. I think most of you would have learned about Garmin fitness device. This is similar to Fitbit. This is specifically popular in US and UK. So this collects data, and within Garmin there are multiple varieties of. They provide a huge variety of Garmin devices for different use cases. For mountain climbers, for walking, for cycling, there are different ways. I'm going to show you a normal Garmin device which collects steps data, heart rate, which calculates how the heart is behaving, pulse, and the sleep time. So these are the basic data that has been collected by Garmin device. That will get synced to a Garmin fitness app. The Garmin fitness app is known as Garmin Connect, and that data will be sent to the Garmin Health, which is the own platform of Garmin. And anyone who anyone who's trying to want to get data of a particular user from Garmin Health, we just need to talk to the Garmin platform as a developer one, and then via the unique authentication that the Garmin has, we'll be able to get the data for that particular corresponding user credentials. And of course, this will have the authentication process inside the corresponding app. Okay. Any questions with respect to till now? Okay. Okay, I'm taking that as an S. Okay, so basically the main focus of this conversation is going to be the communication between the Garmin device to the Fitbit device, because after this, right, it's an HTTPS communication, which we all are much aware about it. So this is not going to be our major focus. Our major focus is going to be about this. But I will, at the end of the session, if time permits, I will show you how Garmin connects to Garmin platform also. Okay. Okay. So I'm going to line out a list of things. Now we are going to come to the testing part. So as the flow goes, I'm going to come up with a set of things which we have to look out for Bluetooth communication testing specifically. And I'm going to give hints and my learning about this. But feel free to raise the hands or raise the question so that I can, if I have the corresponding answer, I can give it now. If not, I can give it after the session also. Okay. So the first thing what we have to watch out for is the Bluetooth version, compatibility and support. Predominantly that the slave device, let's say the Garmin device in this case, right, is going to have a fixed version of the Bluetooth and both the firmware, because most likely, except the latest Garmin device, they don't support the updation of firmware, and also the hardware is not going to change. So even so, we can consider the slave device is going to have a fixed version of the Bluetooth. But in terms of the master device, which is going to be in our case is a mobile device, it's going to have a variety of Bluetooth compatible Bluetooth version, and also the software associated to it. Okay. One good thing is Bluetooth by itself standardize the communication. So in terms of once the data comes into the mobile layer, right, it gives lots of control over that, whatever we can do. But we cannot manipulate the way the Bluetooth communicates, and the communication is same from starting from Bluetooth 2 till Bluetooth 5 version. That's why even now, right, we can use many of the Bluetooth devices that was created way back in previous period. Let's say I have a Bluetooth headset that was done in Bluetooth 2015. Still, I'll be able to pair it with my Apple device or Samsung devices, though the latest mobile devices are having upgraded version of Bluetooth. Okay, but there are things that we have to look out for, because in Bluetooth latest versions, we have the capability to have the timeout period setting and variable, whereas some of the older Bluetooth version, actually starting from iOS 10, right, Android iOS 10, all the mobile devices were supporting 5.2, so it was not of a major issue. But there were some Android devices while we were doing our project which were using 4.2. We were it is as part of the agreement that we have to ensure that those devices were also doing the same. So what we did as part of that, we had a different the Android internal library that to communicate. We find the version that is part of what is the OS devices, then communicate accordingly. So first, before going into any of the project, we have to get the user base, and what are the, once we get the user base, from the user base we can only get to know the model name and the devices. From there, we have to go into one level deeper of what are the different types of Bluetooth version that the older device is supporting. Okay, so that needs to be taken care while doing the testing in terms of strategizing, coming up with the strategy. Okay, and the other thing to watch out for us, so I think, right, in terms of doing the actual data transmission, right, it's pretty simple. Once we have the corresponding developers doing the Bluetooth communication, right, that part I'll come to later. But before that, right, in order to do the Bluetooth communication, we need certain permissions. Okay, first, for doing the pairing, right, peer-to-peer pairing, we need the permissions. So and then during the actual data syncing also, we need the Bluetooth permission. And over a period of time, right, if you take iOS 10, right, there was only control at the mobile level, whereas Bluetooth enabling and disabling, not at the app level to disable the Bluetooth permission. Whereas over the period of time, now iOS gives the capability to control the permissions of each app at the app level and also at the mobile level. We can turn on, at the mobile level, we can turn on, turn off, whereas at the app level, we can give the permission and disable and enable the permissions. Okay. So ensure while during the pairing, you ask the connection for that, because if not, then users will have no clue. So apart from setting the permission to the app, right, we have to trigger it from the UI so that the user is aware of they have to give the permissions. And depending upon the security protocols of different regions, especially in Europe, where we have to follow the GDPR, we have to give upfront information about what are the permissions that is being used in the app and why it is being used. Okay. And when we are coming to the Android, right, starting from Android version Marshmallow and above, along with enabling the Bluetooth permission, the user has to provide the permission of location. Why this is needed is, once we are enabling the Bluetooth permission, the slave device will have access to the MAC address of the mobile device. With the MAC address, there is a possibility we can get to know the location in Android. So that's why specifically we also need the location permission. So just a minute. I'm just calculating the time. I have much more. Okay. Vignesh, you can quickly mention how much time I'm remaining so that I can understand the time, because I have to correlate time period.
You can stop at 11:10, 11:10 to 11:50. You have another half an hour somewhere.
Okay, okay, I have good time. Okay. Okay, and the other thing is, not only during the pairing, after pairing, we also need to check the permission while we are making the data connection. Why? Because there is a tendency from the user side where they can disable the location permission, because in order to save the battery and other efficient usage of data. And the other thing is, when there are certain devices, especially the customized Android OS like Oppo or like OnePlus, once we turn on the battery saver mode, we will not be able to access the notifications or the location unless the app is open in the foreground. So it's better we ask whenever we check the permissions, whenever we are trying to do the data sync, apart from doing the pairing, because sometimes people tend to do, while pairing, they'll start enabling the permissions, and then the person or the technology will stop them to get the data. So it's better while during the data, before trying to get the data, it's better we send the checking the permission again. Okay. Now comes to the actual one, but before going to the actual connection, right, maybe I'll show you how the Bluetooth connection works out. Okay. Maybe I'll show the successful pairing first. Now, what you are seeing is an Android device, and on the left, I think, I'm not sure that there is enough brightness. There is actually a Vivo device there on the left side, which is showing a time period. Now I'm trying to pair with from the Garmin app. I'm trying to pair with the Garmin device. Okay. Okay, I have a question. After this video flow, I will brief that question. So basically what it will try to do is it will look out for the list of devices that is available. And now it has identified this a Vivo Sport device that is nearby. Now I want to do the pairing part. Okay. Okay. Now is it visible? Maybe it's visible. Now I'm trying to do the pairing. Now you can see there is a OTP code or a passcode that is being displayed. Now I'm intentionally trying to enter a incorrect value. So then again, it will show the connection is invalid. So each and every time there will be a new code getting generated, because the Fitbit or Garmin follows a TOTP. Now this also the connections failed, and now I'm going to enter a valid passcode. Now you can see the connection is successful, and it is doing the next set of doing the data connection. I think I'll pass through this. These are basically the setups of Garmin. It will ask whether to allow the notification. We can ask notification is enabled or not. Where do you wear the watch? What is your sleep timing? Basically, the sleep timing is taking from my device, that whatever I've set. Not all the mobile devices support sleep timing, but if you want, we can modify. And where do you wear the watch? What is the kind of look you want? And do you want to sync the data to the common platform? Those kind of things. Okay, and access to the calendar, those kind of things. Okay, and now the syncing is going to be done, because as I told, right, pairing is different and syncing is different. Pairing is making a establishment between the master and the slave, and now what you're seeing is the syncing of data. And now you would have observed there are like 469 steps. So basically it will do the briefing. Now, right, you can see the steps as 469. Can you see the steps? So you can see the steps has been updated. Okay. Now, right, I'll read out the questions. Then I will go for the next set of things. Have you faced any compatibility issues between app and older hardware? If yes, what's the strategy taken to address? And the second question is from Shivram. While trying to connect, did you have any performance baseline? Like how fast the device should be connected? Okay, first I will answer the first question. Yes, there will be hardware issues. Even for Fitbit, there are hardware issues. I will show you a behavior where the successful connection is not there. In this case, right, even with the Fitbit, right, there is possibility of connection is not possible, even after multiple attempts. So if you look at this, right, can you see the screen? So can you see the screen? When we're connecting for the first time, right, Fitbit didn't give us any troubleshooting option. But after multiple attempts of troubleshooting, Fitbit will give an option in the bottom, open troubleshooting. We had a similar handling in our app. What we had is after 5 times of the device not able to do the connection, we will give a list of options and suggestions. And that will be similar to this. First is enable and disable the Bluetooth, or check the permission is there for the Bluetooth. Sometimes what happens, right, the original device would have been paired to the another device. So we'll be ensuring that the disconnection of the pairing is done in the other device, restarting the slave device, that is a tracker device, and then turn on the Android mobile phone or the iOS mobile phone. Predominantly, the issues are observed in Android because due to the way the different OSs and the different layers of the custom layers of Android comes in. But on eye level, the iOS was pretty smooth. Okay, and similar, whatever the methodology that we do for the Fitbit and Garmin, right? The first thing is unpair the device in the original one, restart the device. Apart from that, the one that we also had a check is we are ensuring that there are no devices that is were using Bluetooth older devices. If they are using older devices, we will show them a pop-up. This device is not supported like that. So this is to ensure that the older devices are having enough messages. Okay. Hope I answered the first question. Now I'll go to the second question. In terms of doing the performance, right? There is no direct performance tool. that is available, readily available in the market. There are certain Android mobile applications. I can give some of their names, which behaves as a mobile device by itself and do the pairing and disconnection of those things. Maybe I can show a short video of those things. So I think, can you able to see my mobile device? There is something called as mobile Bluetooth pairing. With that, right, this behaves as a master slave, and we can start the Bluetooth connection, and this will scan the list of devices. What this will do is, this is not specific to any mobile apps, but this is more specific to the Bluetooth technology. So we can use these apps to find out how much of pairing is needed. But with respect to the data connection, right, we cannot measure it using any public app, because the data format and the data and the data, sometimes the data transmission is allowed only after the peer-to-peer connection. So with those apps that I showed you, right, we can test the behavior of the connectivity and the general connections, which I'm going to cover now. But with respect to performance, right, I think what we did in our project is, there are different layers of communications. One will be the pairing part. The pairing part. After that, we'll be going to the connection. After connection, we'll be going to the sending up of server time. Okay, and then we'll be getting the data, and then we'll be transforming the data. Why transforming of data is, it is not one single device that we were talking to. We were talking to a bunch of Bluetooth devices. So we need to have the data in a structured format so that we can send it to the API platform. Okay. So what we did is, in each of the layers, we add a start timestamp and end timestamp, so that and acknowledge. So for each of the actions, right, there will be acknowledgement from the Bluetooth devices. With that, we were able to measure the performance, and with that, we were able to know what were the devices that were taking more time and what are the devices that were taking less time. With this, we were able to come up with a performance baseline, basically. This was the strategy that we followed, but there was no readily available performance metrics that was available as part of the project. Okay, hopefully I answered the second question. So there were two tools that we were using. One is an internal one that was specific to the project. The other one is, in terms of pairing and network connections, a Bluetooth connection, we are using a certain external device. And those devices, those apps are not available for Apple. It's only available for Android. So Apple is more secured in terms of specifying these things. Okay, now I'm coming to the list of things for the connection part. So when it's come to the, as I talked about, right, in Android, there are two ways of permissions we have to set it up the app. Not only in terms of, one is the Bluetooth permission, that is to only to get the data or talk to the device and get the data. The other one is Bluetooth admin, because in our case, right, we have to measure the heart rate and then come up with another data depending upon the age. So what we have to do is, we have to update the data, the year of birth from the application to the devices. So in that case, we have to ensure that we also have the Bluetooth admin permission. Okay. And then comes to the connections after dropped connection. So what is dropped connection is, even while pairing a headset, right, you would have noticed like it doesn't pair always in the first time. So this is like when it's come to Bluetooth, right, there are multiple things that comes into picture. There might be multiple devices around it, and there might be multiple Bluetooth endurance that is possible. So the main thing for us to do is the dropped connection. There are different possibilities for the dropped connections. I'll come to that. But in order to, how do you mimic while doing the testing? Because it's a Bluetooth connection. If you make a stop, if you even disable the internet, right, you'll be able to still Bluetooth will be able to still connect it. And the other one is Bluetooth is not it's not a physical wired connection. So still the Bluetooth connection will be still happening. So what we use something called as Faraday bag. I think this is available in most of the online e-commerce sites. Basically, Faraday bag is used to stop all the connections. Basically, Faraday bag is made up of multiple layers of aluminum foil and other metallic things. If you go and understand the Faraday law, similar to what Manoj was saying, I am not so good at the physics during at my school and college days, but Faraday law says when there are multiple layers of metallic objects, then the radio frequency communication will be blocked. And we have the set of other things that we can come up with. So basically, the Faraday bag consists of Faraday materials, so that none of the outdoor things can come and talk to it. So whenever during our testing, we use this Faraday bag, and we also use some various other strategies, but predominant is Faraday because other strategies were a bit hard to do physically. Okay. Okay. Bluetooth, right? Predominantly the Bluetooth standard communication standards is the Bluetooth devices within 15 meters of range. But certain devices even operate at 15 meters. In fact, if there is Class A communication enabled in certain laptop devices that can even talk to more than 15 meters. So, but the Bluetooth devices, right? The emission of device signals from the device will be around 10 meters. Okay, so this can be used as one of the strategy to make the drop connection. The other thing is make a connection. By the time we get the data, turn off the master device or the slave device. I think the ideal would be to turn off the slave device so that it doesn't give the end response. Basically, whenever there's a connection happens, right, I give a signal start, and to the Bluetooth device that will be giving us end of the communication is done. Sometimes if the end of the communication is not done, right, we can make a retry option, and we can also make the retry option to a particular amount of retries, so that we don't end up occupying the Bluetooth communication for a longer time, so that we can disconnect and make a new connection thing. Okay, and this is what we called as restart. So whenever there is a dropped connection, we have to ensure that the previous temporary state of caching is being cleared, and we come up with a new restart one. Okay, now I'll show you how does Fitbit handles this. Okay, maybe first I'll show you the Bluetooth permission issues. Now this is my iPhone. I'm turning off my Bluetooth, and this is my Garmin app. You would have observed it is showing an error saying the Bluetooth permission is required. Please go to your phone and go to the settings and turn on the Bluetooth. This is one thing. Now, right, I am turning on my Bluetooth. If you look at this, right, this is the dashboard or the home page of the Garmin app. They'll be keep on refreshing the dashboard page so that they keep on know whether there is a stable state or not. Okay. Now what I'm doing is I'm going to the not sure you have observed. I'm going to the app of the Garmin. The app name is called Connect, and I'm disabling the permission of Bluetooth alone. Now I'm coming back to the Garmin app. Now also it is showing the similar message. Basically, right here they are having a generic error message, but what we can do is iOS gives the capability whether the Bluetooth is turned off or the Bluetooth permission is turned off. Depending upon that, we can give up a pop-up in the iOS or in Android asking the user to turn on it. But this turning on the permission can be asked only for the first time. if the user has intentionally declined it, after that, we can only reroute them to the settings page. That's what you are seeing now. Now, if I'm clicking at it on the widget of the Bluetooth permission required, it will directly reroute it back to the settings page of that corresponding app. Now you can see that the error message is no more displayed. Okay. And now we can do the syncing now. Okay. Now I'll go to the other flow of okay, this is success flow. I'll go to the error flow of when there is a disconnection. Okay, now actually, right, you can observe a green color indicator at the top. That means the syncing is available. Now what I did is I put my device in a Faraday bag, or you can take the device after. Now you can see, you can observe the device says it is not connected because I have made the device inside the Faraday bag, and now it got disconnected. Now I'm bringing the device back to out of the Faraday bag. Now you can see, now there is no green color indicator at the top. After some time, it will keep on be polling. Now we can see the Faraday bag, it's come out of the device, and now we can see the sync is happening. And now we can see the data is also being transmitted. So on eye level, right, these are the strategies and techniques. But the one thing that I told you is a Faraday bag. What Faraday bag does is immediately interrupts the connection, and immediately the connection goes off. But if you want to do it in a delayed manner, right, you can do various approaches. What we did physically is we will move to the lift or give my device to a person who can travel in the lift, and the communication will be like slowly getting down. So these are the various types of connection interruptions we try to mimic, so that these are the things that is possible. And the other thing is, after getting the data from the Bluetooth, right, the flow doesn't end up there. There are two things. One is, if you look at the app now, right, there is a green color indicator and there is a sync blue color indicator. What does the green color indicates is the connection between the Bluetooth device, and the sync indicates the internet connectivity. The flow doesn't stop after the data coming from the Bluetooth device. We have to ensure the data goes to the Garmin platform also. Similar to the Garmin platform, we had our own platform. So what Garmin does is, he has a local cache. So different Fitbit devices has their own caching. That's how they handle it. But in our cases, right, we'll ensure that the device is turned on, and the user is sending the data to the server also. Okay. Now coming to the server, right? Okay, with respect to the time constraint, I'm going a little bit fast, but feel free if you have any questions. Even if I'm not able to answer it, I'll answer it post the session. The first thing we have to do is, all the personal Fitbit devices or any devices, right? If you look at this, they send the data in with the timestamp will be always in the the base time, which is the GMT, but it doesn't mean the user who is using the app or the consumer will be in the same time. The first thing we have to do is, before each and every thing is, set the data in the device with respect to what we are having. And in our case, right, there are two ways we can set the data. Excuse. Either we can set the data what the mobile devices have, or get the data from the server. What we did is, we always get the data from the server as part of our app, right? We will get the base region of the user, because the user might be anywhere in the Europe, because the users might travel across anywhere in the Europe easily. But what we will be saying explicitly saying, right, the base time will be whatever the user sets it up while during the setup, because the time reference in Europe will be varying across the regions, and that time will be the source of truth for the server to get the data. Okay, so ensure you're setting that the date and time, because the mobile devices and the actual tracker devices allows them to change the data. Okay, and coming to the data, right, the customized devices what we are having can store only up to 7 days of data. It used to collect steps data, heart rate, and sleep time. So in this case, right, it becomes tricky. So people can change their device time, or if the device turn off completely, right, and there is a battery reset time which also note down the time, but even that there is a period. So when we are syncing the data again, right, let's say today is Saturday. If I have synced the data lost on Monday, right, I'll be able to get the data. But let's say I synced the data lost on last week Monday, I'll be not getting the data on for the previous week, but I'll be getting data starting from Monday if I have used the device properly, and the device has data. So and different devices, right, send the data structure in a different way. Suppose if they don't have a data, sometimes you can consider it as an empty array. Some devices, if they don't have a data, they give it as a null. So ensure you understand how each devices sends the data, and ensure you have the corresponding handling at the mobile level or the application layer. Okay, because we cannot control the mobile devices because it is fixed. It is only the mobile device that can understand the various different types of condition and logic and then get those data. Okay, and when it comes to the communication with respect to mobile, right, we have to be very careful about the security thing. Ensure that device always gives a specific name, because each device will have a Bluetooth friendly name and a MAC address. Ensure you get so in our case, right, though we have multiple devices within our cluster, right, first we will ensure we will only filter the Bluetooth friendly name what we are supporting. And let's say if you had seen the Bluetooth pairing, right, within Garmin itself there are multiple devices, and we have to filter within our device cluster. There are multiple devices, each were starting with their own individual Bluetooth friendly regex. So what we do is, once we select the device, we'll search for only those specific Bluetooth friendly devices. These are the things that we have to do. And similarly, right, once we pair with the Bluetooth device, we'll also register that device name and address to our common profile at the server. And this also needs to be encrypted, because nobody, though it is a HTTPS protocol transmission from the mobile to the server, ensure that you are encrypting these things. Okay.
Bharathan, just a quick time check, Bharathan. Sorry to interrupt.
So how much time I have? 5 more minutes?
Maybe 2-3 more minutes, because if you have any Q&A at the end, they have to answer those also.
Sure. I think this is my last topic. I'll go to the Q&A. And the final thing is, ensure while you're sending data from your mobile device to the server in a whitelisted format, so that you don't send data to any other platform. Okay. And there is also something called as blue jacking, I think, which we don't need to worry about. Each OSs handle it. But as long as you give a proper information while during the pairing, that this is how the name will be displayed and this is how the connection happens, that will ensure that the user is not giving access to any of the other Bluetooth devices which are nearby. Okay. I think this is just a list of things that whatever we have gone through. Like we went through the Bluetooth version, mobile specific permissions, connections, server time, how the data is being cached and how to handle those data caching, and what are the security things that we have to be coming up in both in terms of the user flow, user experience, and in terms of the platform we are creating. So we have to be very careful about in terms of security, especially when it comes to the GDPR. I think, right, there are many things that I'm still planning to do. If time permits, right, I'll come up with another session, but I'll stop with my session right now. I'll open it for Q&A for now.
Guys, it's time for the Q&A. If you have any questions, please put it up in the Q&A. Bharathan will be happy to answer those.
Okay, I think. Okay.
We'll wait for we got a question, Bharat.
One question, Vigesh, I'll try to answer that alone with respect to time constraint. Why the Bluetooth connectivity range is constrained between 10 to 15 meters and not beyond that? This goes back to the frequency range that we are communicating. So the Bluetooth frequency range is between a particular range. For that range, right, the signals will be strong enough only for that particular 10 meters to 50 meters of distance. After that, right, there might be pocket losses in terms of the data transmission. That is the prescribed data range. That's the reason. There are, if you look at the RF frequency, radio frequency communication, there are wide range of communication. There are infrared rays, and then comes the Bluetooth, and then comes the wireless, and then comes the actual mobile communications and satellite communications. So the Bluetooth operates in a specific range. That's why the distance is being restricted. Okay, I think I'll leave this session. Thanks everyone for joining the session. I think if you have any other clarification, please reach out to the vodQA team or to me, and I'll be happy to help you out. Okay. And last but not least, I have to give the credits. When I started this project way back in 2019, I saw a blog in Atomic Object. That person is Jordan Skenden. That blog helped me in lots in terms of understanding how the Bluetooth works out. And then another co-worker of me from China office, Lan, I was pairing with more of us. I think I have to give the credits to these two persons in terms of all of the knowledge and experience that I shared with you. And I think with that, I'll close mine. Thanks a lot. Thanks a lot, everyone. Bye-bye.